Hi everyone, in this video I'm going to go through questions 4 and 5 of exercise 1E of PO2. So question 4 is basically is a classic question on differentiation topics, which is about finding the derivative of a curve at a specific point. So in this case, the curve has the equation y is equal to x plus 3 over 2x plus 1 to the power of half, and we want to find the value of dy dx at the point 12, 3. Okay, so in these types of questions, the first thing that we basically need to do is finding the gradient or dy dx. So I mean gradient function and then gradient itself. So we need to find the derivative of y with respect to x. And this is a quotient, we need to use the quotient rule for the differentiation. So as I have done this multiple times in the previous videos, you first square the denominator function. So in this case, if you square the denominator function, it's just going to be 2x plus 1. Then you write basically the denominator function times the derivative of the numerator function. So the numerator function is x plus 3 and it differentiates to 1. Very simple. And then this minus, now you start with the numerator function this time, and this time times the derivative of the denominator function. So denominator function, we need to use the chain rule to differentiate 2x plus 1 to the power of half. So the half comes down, and the derivative of inside the brackets is just 2. So that also comes out. And then inside obviously doesn't change, but the power, we need to take 1 away from that. So a half minus 1 is just a minus a half. So this is the derivative. And I'm not going to simplify this. But we are not done with the question yet, because the question says find the value of gradient at a point 12, 3. So if you want to know the gradient, we first need to have the gradient function, which we do in this case, that's dy dx, and then we need to have the point. So the point is 12, 3. So the point is 12, 3. And since we only want to know the value of dy dx, or the gradient, we only need the x in x coordinate. In fact, even if we didn't have 3 for the y coordinate, there wouldn't be any problems. So we only need to substitute 12 into dy dx. So we can write when x is 12, then dy dx is going to be, so if you substitute 12, and if you like, you can calculate that. But yeah, when we substitute 12 into dy dx, we'll get 2 over 25 for the value of the gradient. And that's it. That's the answer to this question. Now the next question is 5, which is similar. Find the stationary points of the curve C with equation y is equal to e to the 2x plus 3 over x, where x is a non-zero value. So here we need to find the stationary points. So again, a stationary point is another key term whenever you see you should be thinking of differentiation. So if you want to find a stationary point, we need to differentiate the function and set that equal to 0. Then solve the equation, and the x coordinates that we are going to get are going to be the x coordinates of the stationary points. And finally, we need to substitute the x coordinates into the main function to get the y coordinates, which basically gives you the y coordinates of the stationary point. Okay, now we need to differentiate this. Again, it's the quotient rule. So we square the denominator, which is x squared. Then we write down the denominator function times the derivative of the numerator function. So the derivative of numerator function is an exponential function. So we differentiate the power, and then that comes down as the coefficient of the function. So 2x plus 3 differentiates to 2. Then obviously we need to write down the function itself. Then the entire thing minus This time, write down the numerator function times the derivative of the denominator, which is just 1, because that's x, and that differentiates to 1. Okay, at this point, we have basically the equation of the gradient, which is dy dx, and we want to find that stationary point. So to find that stationary point, we set dy dx 0. So let's do that. We are going to have x squared, then on top it's 2x e to the 2x plus 3 minus e to the 2x plus 3 is equal to 0. So we do a cross multiplication, and that cancels out the x squared on the denominator. So we are going to get 2x times e to the 2x plus 3 minus e to the 2x plus 3 is equal to 0. We can factorize this, so take a factor of e to the 2x plus 3, then it's going to be 2x minus 1 is equal to 0. So this is the interesting part, because if we want to solve this equation, there are two cases. Either the term on the bracket is equal to 0, or the other term is equal to 0. So if you solve the first equation, obviously x is equal to a half. That's one of the stationary points. But the other one is interesting, because we have e to the 2x plus 3 is equal to 0, and this is not correct, because we know that this value is never, e to the 2x plus 3 is never going to be equal to 0 for any x value. So that's not possible. It's always positive. So since e to the 2x plus 3 is always positive, then this equation basically doesn't have any answer. So the equation doesn't have any answer. So what this means for us is that the only stationary point of this curve is x is equal to a half. So I mean, it has the x coordinate of x is equal to half. So in order to find that stationary point, the coordinate of the stationary point, we need to substitute x is equal to a half into the main function, which is here. So this y is equal to e to the x plus 3. So we substitute that, and let's see what we get. So we are going to have the denominator is x. So basically, since the value we are substituting, so let me write that down just to be more clear. When x is equal to a half, what we are going to get is this. So y is equal to a half in the denominator, and then in the numerator is e to the 2x plus 3. So it's e to the 2 times a half plus 3. And let's simplify that. So on the numerator, it's just going to be 1 plus 3, which is e to the 4, divided by a half, which is 2e to the power of 4. So this is the y coordinate of the stationary point. And finally, the stationary point is, so for the stationary point, the coordinates are half and 2e to the power of 4. Okay, so that's it for this video. Thank you for watching.